Okay, so we're here to start soldering. So turn on your soldering iron. Remember what we said about tinning and keeping the soldering iron tip nice and clean. Have it all tinned up, warmed up, ready to go. Wet your little sponge so you can wipe your soldering iron on it. There's a little sponge. Make sure the tip is nice and clean. Now, I'm just going to use some 22 gauge wire for this first one and get this started. Especially if you watch my first videos, you should know how these little wire strippers work. But what we've got some 22 gauge wire, and we know it's 22 gauge because we just tried it on the stripper and saw which hole worked. This is a stripper we got from Radio Shack a long time ago. It has numbers right around here. You can just set it to the 22 gauge. Yep. So there you go. You can see the 22 on the dial there. You just set that so that the flat on the little dial meets the flat on this. Or if you have one with the holes in it, choose 22 gauge. And just strip your wire off. I usually use like about it, maybe a little over a ½ inch that I strip off is my normal. And what you get is your wire like this. Okay, so we're just going to twist the strands of this nice and neat so that they're all together as one thing. We're going to do that with both of these. Sorry, my table's a little wobbly here. I had to do this in a place where I've got better light than I do on my workbench. So we're going to twist this one the same way. We're going to twist them together. And the thing here is to make a nice, neat connection, not a lumpy one. That way the heat shrink will go over it easily. Oops. Of course, you might want to do it so that it's actually maintains its twist, which just means I didn't twist it tight enough because I was trying to do it on camera. Make it look easy so, but there we go. Okay, so hopefully this will work and you can see it okay. So we're going to apply the iron underneath. A little bit of heat. We're going to heat up the connection. Give it a minute. We're going to apply the solder on top. And you see it runs along the wire. I don't have to apply it to where the iron is. You want the wire to be hot enough to melt it, but don't leave heat on too long or you melt the insulation. And that's what you want it to look like. I know this camera isn't exactly a prime model, so this is about the best picture I can get you, but what you want is just like that. What's harder to see is that on the strands of the wire there, the solder has soaked in and it has taken on the shapes of the strands of the wires, so you can see the strands of the wires through the solder almost like grain in a piece of wood. The idea is the solder has wicked along, and so you get a nice good connection. Don't apply over much solder or it'll cause you other problems. Also, when you finish this, you don't want to bump the connection for just a few seconds. It's already hard by now. But for a few seconds, you don't want to bump it. When you take the iron off from underneath, you want to take it straight down so you don't bump the connection, because the slightest movement of that connection before the solder has reached solidity, and it'll cause what's called a cold connection. And then instead of shiny and nice and silvery looking, it'll be kind of a dull grayish color. And that's what you want to avoid. And since you used your solder with resin in it, which is proper for electronic soldering, then it should have made a nice smooth connection. Then simply slide your heat shrink over it, and don't use black tape for this. Black tape is a last resort. Okay, so again on the heat shrink, you need to be careful not to apply too much heat. I'm going to use a lighter here, and we'll just apply just enough to get it to shrink. Notice how it shrunk, and help squeeze the wire a little bit, wire change shape a little bit because it shrunk. So looks like it needs a touch more on this end. You have to watch out. Don't start it on fire. There's also some other tools you can use for shrinking the heat shrink. One of them is a torch type of tool that has a hot air blower on it. Okay, now we're going to show what it takes to remove and replace a part on a circuit board. Now, we're going to start with what I consider to be one of the worst methods, but it works. And that's this what's called desoldering braid. And the way it works is, we'll not use it to take something out, but I'll show you on the solder connection right here. What you do, you heat the soldering braid up, you put it on the spot. But yeah, unfortunately your braid gets oxidized and then it doesn't work very well, and that happens over time. So but it's also not hard to find. I put some flux right on the braid, so we'll see if that helps at all. Yeah, that's better. So then that would be a more recommended way to do it. Just have a tin of flux like I do right here. There we go. Now that's how that's supposed to work. I can't really get you any closer than we are on this, but if you look right there at the tip end of the soldering iron, you can see that the solder has now been removed from that little connection and it wicked away by the braid. But because our braid was oxidized, it wouldn't go well on its own, so I rubbed some of this tinning flux into it, and that was enough to get the desoldering braid working. So I'd recommend, if you have to use it, to go with that. That actually worked pretty well with rubbing the flux into it. That's the first time I've tried that, because I don't think I've had any that's been oxidized enough to be a big problem before. So, okay, you've got a method. So we're going to remove this big blue capacitor here, just because it's big and easy to see. And so I'm assuming you're taking out a dead part that somehow you've determined it to be dead, or it's broken or damaged or something. And so by looking at it, you can see that there's two pins that need to be heated up to remove that. They're in there. So it's one of these plunger types. So yeah, so what you do is you push the plunger in and it makes a vacuum. Then you place the end of it on the solder connection and release the plunger, and by pushing this little button right here, plunger pops out and it sucks up your solder. Let's see if we can get this to work properly now. There we go. I don't know if you can see that, but right there There is now a hole where there was solder. The only question is, did I get the right lead of our capacitor, or did I get something right above it? Yeah, I got the wrong one. Okay, but that's how it's supposed to work. That's basically it. Get the majority of the solder off there. If you have a 3 lead or better thing, you're going to need to work the solder off more, but for just 2 leads, you can do that. This thing is just too flexible to work well with this. You should be down flat instead of having it up for a camera. That's the idea. Let's see if we can get you. It works better if you push it down, get our holes cleaned up a little bit. So whatever method you use, you can see now we've got our holes back through, they're cleaned up. So then you can take your new part, assuming this was our new part. This is a capacitor, so if you're putting in a capacitor, you have to pay attention to the polarity. But you want to watch out on a circuit board, of course. And don't use more than like a 60-watt iron at the maximum. Because if you do, you're asking for trouble. Okay, so now we've got our capacitor pins poked through the board. Don't use too big of a soldering iron or your traces will come off. This is a capacitor, so it's not a sensitive component. Just apply your little solder there. Let it wick between the connection and the copper trace underneath. We're going to put our solder back in that spot. You need to be careful. You notice that a lot of these traces are very close together. You need to be careful, number one, not to touch another trace with your iron. Never work on anything with the power on. And make sure your solder only goes to the trace you want. Do not use excess solder. It's really easy to bridge 2 of these. Maybe I'll just show you how that works. Let's see, these 2 are really close together. Can you see those on here? Now let's get something down here. There. It's actually easy to do by accident at times. That was just not the best spot to do it. And I avoid doing that, so it makes it hard to do it. But you can see how that spot there is now connected. So those 2 traces are now connected, and they're not supposed to be. And if you do that by accident, just get your solder sucker out and hit it. Boom. There you go. Your traces are no longer connected, and a lot of times I'll take like a penknife or something, a pocket knife, and just scrape a little bit along the edge, make sure those aren't connected. You don't want to accidentally cause a short. And then there you go. You got a good repair. You need to remember a couple of things. If it's a sensitive component like a transistor, you should be using a anti-static strap and potentially a grounded tip iron, which this is. I guess that's all for now. If you have any more soldering questions, let me know. And please feel free to comment and we can go over them. Thank you.